In this video, I'll be going over how to adapt and assemble an example of a 3D printed switch. So the way I structure this presentation is first going to go over the list of materials you'll be needing, and I include all this in the description below. And then after that, we're going to go through the quick process of adaptation and sort of what the finished product looks like. And then we're going to adapt the switch and assemble it step by step. So with that being said, let me just go through the materials very quickly, and then I'll transition to a closer camera angle so we can see really close up what's going on. So first, you're going to need a ruler. You're going to need a 10-foot male-to-male cable. You need wire cutters, wire stripper, helping hands toolkit. You'll be needing a micro switch. You may be needing a filer. You'll need soldering equipment, so soldering iron and solder. And then lastly, you're going to need the 3D printed switch parts. So this particular switch is made by a French company named Ergo, and the switch comes in 3 different parts. So you have the switch base, which the micro switch inserts into and the wire comes out of. You have the switch button, which is essentially the button you would press. And then you have the switch cap, which sort of locks it all in. And so when it's in its finished product, as you'll see in just a second here, you would essentially click this down, and that's how the switch would be activated. So now that we know all the materials we'll be needing, I'm gonna put these out of the way for a second, and I'm just gonna briefly talk about the process of adaptation and what the finished product looks like. All right, so now that everything's out of the way, I have 2 schematics here. So first going to talk about the exact process of adaptation. So essentially in this top schematic here, we just have the micro switch and the end of the male cable. And this is essentially the end of the switch, which would plug into whatever you needed to plug into. So you have the micro switch here and the male cable here. And essentially all you're really doing, if we take out the switch parts, if we take those out of the equation, is you just have to strip the end of the black wire off to reveal the inner wires, so the red and copper wire here, and then you end up soldering to the ends of those wires right onto the end of the micro switch. And so it's actually a fairly simple process of adaptation. You're only stripping the end of this wire and then stripping the end of the red wire and then adding some solder right onto the micro switch, and that's pretty much it. So that's essentially what you can expect to see in this presentation. And I'll put those to the side for a second. I also want to show you what the finished product looks like before we actually get started on it. So right here, I opened it up, but as you can see, we have the micro switch connected to the 2 wires, the 2 solder points, and then the wires loop through, and the cable is very taut here, so it can't be pulled. And then you would just close up the switch here, and essentially that's how it functions. You plug it in, activate it, and that's how it works. So now that we know that's how it works, I'm gonna switch the camera angle and show you a little bit closer up of what we're gonna be doing. All right, so now we're a little bit closer up so we can see a little bit better of what's going on. So first materials I'm gonna get started with is actually the micro switch here. Also a filer you may need, and the base, 3D printed base. So first, when we're working with the micro switch, micro switches can come in different shapes and sizes, so you would get the size that I include in the description below. However, different micro switches may have different ends here, as you can see. In this case, there are actually 4. And so for adapting a switch and assembling it, we're only going to be using 2 sides or 2 prongs, so we can actually break the others 2 off. So I'm just going to sort of get them in this prepped position, and suppose I'll just break these 2 off. So the way you break it off is you push it down, pull it back up, repeat that, and essentially it'll just fall off. So you do that with both sides on one end. And so once you get that off, you essentially finish that step. And if your micro switch already came like this with 2 prongs, don't worry, you would just be on the step I'm on right now. So now at this point, you would bring the 3D printed switch base in, and you would test to see if the micro switch can fit into the switch base. In this case, mine can't because it's just a little bit bigger than the indent here, but if yours just fits in, like for example, if you can push it like 1/4 of the way in here without it getting stuck or anything, and the tension's pretty good, then you would move to the next step. But in this case, I can't because the switch is just a little bit bigger than the indent. So in this case, if this happens to you, you would just simply use a file and file the end off here. So I'll do this off camera and I'll cut to the part where I finished the filing. All right, so I finished the filing. As you can see here, maybe a little bit difficult to see, but I just used a filer and just repeatedly just go in one direction for each of the sides, just to pretty much file down a little bit of the edges. Also work on the edges here, as you can see. And pretty much just keep filing down and keep testing with the switch base here where you can actually get it in. So as you can see, I could fit it about a fourth of the way, halfway in without it getting stuck like it did before. So that's how I know I filed enough. Of course, you don't want to file too much to the point where the Microswitch is actually moving around there. You want it to be pretty taut in there. As you can see, it's pretty stable in there. So you want to file it just to the point where you could just fit it in. All right, so now that we finished that, we're going to be putting the Microswitch and the switch base away for a while until we come back to it later in the presentation. So what we're going to be doing now is we're going to be using the 10-foot cable, as you can see here, and also the ruler. So put the ruler to the side. The first thing you want to do, of course, open the 10-foot cable. And after you open it up, we're actually going to cut it halfway through. So this can actually be used, because it's sort of two ends to the 10-foot cable, it can actually be used for two switches. So you'll essentially have two 5-foot wires, and you'll have about 5 feet coming out from the point where you solder with the Microswitch. And so it's pretty good. So it's like 2 for the price of 1 pretty much. And you have about almost 5 feet of wire to work with. All right, so I got to the middle of the wire. I just stretched it out off camera until I reached that midpoint. Of course, if you wanted a little bit more wire on the switch, you could cut a little bit more. But I'm just gonna cut down the middle. So I have 2 5-foot wires. Again, just cut completely through to cut the wire open. You can discard 1 wire for now because since we're only doing 1 switch, we're only gonna need 1 wire. Again, you can use the other wire for another switch. All right, so now that we got the wire here, we're gonna actually be working with the end here. So this is the switch end, which would plug into the device or the toy or whatever it would be. And so we're gonna put that to the side. We're gonna be working with the end here. You actually see a couple wires within there. And what we're gonna wanna do is access these wires. And so to do that, you can use the wire stripper or the wire cutter, because as you can see, it's a little bit hollow there. So you could actually cut into the side of it just to reveal the inner wires, or you could use the wire stripper, but you have to be careful at this point because if you use the wire stripper, you might strip off all the wires, and you just want to get this black insulation. Just get this black insulation off to reveal the red wire, and there's a copper wire as well. And so for the measurement, you're going to be doing about 1 inch here. So in this case, I'm going to use just the wire cutter and just reach the edge, but you can use a wire stripper if you feel more comfortable with that as well. Just very lightly cut the end here, and I can break it open a little bit, and so that's exactly what I'm going to be doing. Use my fingernail to sort of get a little bit further in there. May have to cut a little bit more with the wire cutter here, but that's fine. And again, if you're using the wire cutter, you don't want to be cutting the copper wires within. You just want to sort of work your way around the black insulation cable and try to take it off like I did there. So if you have a little bit end here, you can cut that off too because we're not going to be needing it. So I'll do that right there. There's a little bit more here, so I'll cut that off too. Pretty much just cut the black insulation wire off as much as you can to the point where you just have the outer wires here. So this is about fine. At this point, you may have a red wire or a black wire, or you could actually have a red wire and a bunch of copper strands. So for the product I purchased here, it's a red wire with a bunch of copper strands. So the first thing you want to do is actually twist the copper strands together. So try to work near the base and see which side they're coming out of. And once you find that, try to loop them around. It's very important to do this correctly because you don't want to have the copper wire touch the copper within the red wire, because if that happens, then the connection is disrupted. So twist these together and use your fingernail. I also like just twisting the base of it below. All right, so essentially what I did, just trying to make it very compact, very taut. There we go. All right, so we did that. And now at this point, we're gonna be stripping the end off of the red wire to reveal the inner copper wires. Maybe a little bit difficult to see, but essentially there's copper wire in there just like there is here, except there's just a red insulation. And so we're gonna be stripping about 1/8 of an inch off. So about right there. In this case, you could use the wire stripper or you can use your fingernail. In this case, I'm gonna use my fingernail just because it's a little bit easier. Just gonna put a little bit of pressure in and just pull. There we go. So you can see the copper wires just like the copper wires here. So I'm gonna put the red insulation to the side, just twist together lightly. All right, so now that we finished that part, we're actually gonna get into soldering. So I'll briefly explain soldering as I plug in my soldering iron. So you can put the ruler to the side here. What we're gonna be using is the Helping Hands toolkit, if you have one, the main wire, and then the soldering equipment. So first thing you would wanna do is hold the wire here in place. So this is where the Helping Hands toolkit is very helpful. You essentially use the end alligator clip to sort of suspend it in the air as you end up soldering. So you end up soldering, make sure the wires are all together. You don't wanna have little frays coming off, as I mentioned earlier. So that should be fine, and separate the wires as well. And so now I'll get my soldering equipment here. So I have the soldering iron in my right hand, which you hold like a pen, and have the solder on my left hand. So which is essentially a spool of very thin conductive wire. And so what happens is as the soldering iron heats up, which is again in my right hand, I would press the solder into the soldering iron, and it would essentially melt it as the soldering iron reaches a very high temperature, actually the point where this metal here melts. And so you would essentially melt it right on top of an electrical connection. So you would touch the solder to the soldering iron right on top of the connection, and you would actually melt this metal right on top of it. It would perfectly coat the ends of the copper here. That's essentially what you're doing with soldering. Of course, you don't have to solder, but the best thing to do in this case is to solder, because it helps keep the connection stable and also helps preserve the current within there because it's a conductive material. All right, so hopefully at this point my soldering iron has heated up. And so you can either start with the copper wire here or the red wire here. In this case, I'm just gonna be doing the red wire. So again, as I mentioned, I'm gonna be touching the solder, again in my left hand, into the soldering iron and just covering the end here until you get a little bulb of solder there. So if you can see this little bulb I sort of created, I want a little ball at the end because we're actually going to end up soldering to the end of the Microswitch. So it's important to have a little bit extra there. And at this point, I'm going to be doing the same thing on the other side. Just covering, instead of covering the whole wire, you don't have to do that. You just cover about the same length as the other side and just get a little bulb in at the end as well. Okay, it's about the same length. Get a little bulb. There we go. So you got the same thing on both sides. And now at this point, we're actually going to bring in the Microswitch that we prepared from earlier. All right, so here we go. Here's the Microswitch. And at this point, we're going to be using the other end of the Helping Hands toolkit. I'm going to be holding the Microswitch in place because I'm actually going to be soldering to it. So I can actually take this wire off here for a second. And so I have it sort of set up here. There we go. Now at this point, we're going to end up soldering to these 2 points to the ends of the micro switch. So it doesn't matter if you have the red wire on bottom or the copper on top or vice versa. You just want to connect one end to one prong and the other end to the other prong. So in this position, I suppose I'll just solder the end here with the red wire to the bottom prong. And at this point, I'm not using the solder, I'm actually just melting the metal. So I sort of just touch the ends of the bulb, and as it melts, it sort of melts perfectly onto this end prong of the micro switch. So as you can see, I try pulling it. It's a very stable connection, which is good. You want to try to coat the end prong of the micro switch, as it's going to hold it in very well. And do the same thing for the copper wire. All right, so there we go. I could add a little bit more maybe to sort of solidify where it is, so I guess I'll do that. And just try to perfectly coat it right on top of the end prong of the micro switch. All right, so now that we got that done, test to make sure the copper wires from the main copper wire, or you may have a black wire, aren't touching the copper wire from the red wire. As I mentioned earlier, if these touch, then the circuit will be disrupted and the switch won't be able to activate properly. So there we go, we got that done. And now we're actually going to be placing the micro switch with the cable into the base of the micro switch. And so this is why I sort of wanted to file the micro switch before, because obviously if the micro switch is a little bit bigger than the indent here, then you don't want to solder and then have to, work a little bit harder to sort of file the ends here. So now that we know the micro switch fits well into the base here, I'm just going to lightly place it in as far as I can, pretty much. And also, if you may have soldered a little bit to the left here or to the right here, and that actually may interfere with the base of the micro switch, the little indents in here. In this case, I think I'll be fine, but if that happens to you, then just solder a little bit closer to the middle, but again, you don't want the ends to touch. So essentially that's what you would do. And now at this point, you press the micro switch in as hard as you can. Don't press it in with this way because you actually may break the switch. So sort of the best way to sort of force it in there is use a tool like a screwdriver, or in this case, I'll just use the wire cutters, and just get the ends here and really force them in, because the tolerances of the top of the switch and the top of the micro switch here are actually very precise. So you really want to force it in as much as you can. So really put a lot of pressure in. And again, don't actually touch the point where you would activate the switch, because you may actually break the switch. So there we go. I sort of just forcing the wire cutter into the end here, into all four ends, really as far as it can go down, just so it's sort of situated the best that it is. All right, so there we go. Now that it's really forced in there, again, test to see if the micro switch works. If you hear the clicking, that's how you know it does. And now at this point, we're going to loop the wires through the indents. In this case, the path of the wires would actually be following my left finger here. So it's through this little indent here, and then along this path here. And so I loop it around. Again, you don't want the wires to necessarily touch each other. And hopefully you cut the right amount of wire, because if you did, then you'll sort of have the black insulation cable be right here. And so at this point, obviously you can't really fit it in, especially if you're using the black cable that I am using now. So what you actually have to do is sort of mash it in there. And so you can use the wire cutter here, or again, a screwdriver. And just like we did with mashing down the micro switch, you essentially just want to do the same thing. And so just forcefully pressing into there. Try to go near the edges of the wires, because you don't want the wires inside to necessarily break. But the reason we're doing this is because we want the wire to be very taut within, so that if you pull the wire, you're not pulling on the connection, right? And so if it's very stuck in here, you'll actually be pulling on the end here, and so it'll just be pulling there instead of on the main connection. So I'm just gonna try to force it in here. There we go. So really press hard down into it until it's pretty much touching the base floor of the switch. So I'll update you with the progress as I go along. Again, just pressing very hard down into it to the point where the black cable is touching the bottom of the switch, and just keep going along as you reach sort of the end or that opening. And so as I get to the opening, I'll show you in just a second. There you go, I'm reaching the opening. And so what I'm gonna do is I'm gonna sort of push down on the end here. You don't wanna push down here. You wanna push down still wire inside the switch. That's exactly what I'll do. Over time, as the switch wire gets pulled, you don't wanna be pulling on the connection, of course. So you just wanna press down here. It's what your final product should about look like. So as you can see, it's very forced down into there, and that's sort of what you want. And you want it to be on the base as well. So at this point, just go another time around, just making sure it's really down into the base of the switch. Hopefully it is at this point. In this case, this looks pretty good. Not really any exposed areas, but again, it's very taut. So as I was mentioned before, if you try pulling it, it's gonna pull in this area, but this area is so well secured in there that it's not even gonna be making a contact on pulling the connections. So it's pretty much what you would wanna have at this point. And then finally, we're gonna actually end up closing the switch. So we got our last two materials here. We have the switch cap, which actually has the letters on the end here. You have the switch button and you have the switch base. So you essentially fit together the switch cap and the switch button like this. Just push it up into it. It sort of has a nice ridge there. And then you line it up here with the letters coming out of the hole. So, and you just press down. It take a little bit to find that, find the ends where the ends meet. And so just press along as you find where to hit it down. As you can see, I hit it down here, and now we can actually test the product. So you may run into some issues here. If the cap of the switch does not completely go down, or you still have like a gap here, even if you're pushing really hard, what you would have to do is you would have to end up pushing down the micro switch a little bit more. So to open up the switch, you have to press very hard on one end, and you can actually sort of force it open that way. And so the problem there would be is you would have to push down the micro switch a little bit further. Again, as I mentioned, the tolerance is really tight. Some other errors with some other things that could happen with the switch. If it's not working in whatever purpose you want it to be used for, you would have to check on the wiring within. There could be a possibility that the prongs are detached from the micro switch, so that would be a mistake and you couldn't really fix that. However, the mistakes that you could fix is ones that if they're soldered together, you could easily just break the solder point by just adding the soldering iron, and you would separate it. If the wires here are touching, so copper wires from the red are touching copper wires from the main copper or the black cable if you have it, what you could do there is just try to separate it maybe with some tape, and hopefully the connection will be good. And those are pretty much the main errors that I've encountered with this switch, but the switch is very high quality if you prepare it correctly. And pretty much if you do all that well, then you should have a very good functioning switch that should last a long time. And in a future video, I'm actually going to be going over how to mount the switch on a very cheap and very accessible GoPro mount. It's actually with these two holes here. And so keep a lookout for that video. And again, all the resources are going to be in the description below, all the materials you'll need, as well as how to actually access all the 3D printed switch parts. And I also have additional resources there, including a step-by-step presentation in case you wanted to follow that, or a very detailed list of typed instructions of how to adapt the switch as well. And thank you so much for watching.